delay, my laptop died. Yeah, this question. So I told you I'd look at it once I got off and make tracks. I don't know how they're solving this. I haven't actually looked at the scheme for this one. Sorry, that thing is jammed again, so I'm just going to close it down when I'm talking to you. I haven't looked in the scheme in this one, and I'm sure I'm just overthinking it, but I kind of felt like I had to do calculations to wrap my head around it. So I'm just going to show you the way I went through it, just to figure out that these two triangles were similar. Is this going to work? Go away. Okay. That's the previous one. Right, so what I have here is, so this is FEA, which you said was 90. FEA is this one over here in the little triangle. So if FEA is 90, then this one up here at A, the blue one, and the red one down here at F, if I add those two together, I have to get 90, because a whole triangle is 180. This little yellow kind of backwards L here means that this is 90, so the other two added together have to make the other 90 of the 180. Does that make sense? So I have the red angle, or sorry, oh my god, I'm tired. The blue angle, which is EAF, plus the red angle, which is AFE, has to equal 90 degrees, because FEA equals 90 and a whole triangle is 180. Same theory in the big triangle. AED, this one here is 90, so then the red and the blue added together both have to make up the other 90. So I have the red EAD plus the blue EDA, equals 90. And what we're trying to prove, so that's still over here, what we're trying to prove, I have it color coded, is that AFE is the same as EAD and EAF is the same as EDA. So like the fact that they both add up to get 90, I don't know if you can make a leap and say, okay, they're equal, because I'm like, now this is just my head. I'm trying not to go too far into, like, could this not be 60 and 30 and this one be 40 and 50? Like, those numbers still add to make 90, but clearly 60 is a different number from 40. Do you know what I mean? So I was kind of struggling to go straight to, like, it feels like the kind of question where I should be able to go, therefore they're similar. But I think I can't wrap my head around it. Now, it turns out they are, of course they are, but I sort of needed to prove it. So what I did was I did a little bit of trigonometry. I took, what am I in? Sorry. I took the little triangle, F, E, A, and we know that this is 12, this is 5, and this is a right angle. And this one down here I have marked as red, yeah? And that's that, AFE, right? So I did tan. I don't know how much you know about trigonometry, but this is the hypotenuse, this is the opposite, this is the adjacent. So the tan of the angle is opposite over adjacent. So, the tan of the angle is 12 over 5. So the angle is the inverse tan of 12 over 5. So the angle is 67.38 degrees. Right. So this one here is 67. Oh, sorry. I didn't realize I was delayed. The internet's good crack tonight. Yeah, so I took the little triangle. The fact that I had two of the sides meant I can actually use trigonometry to find the angle, to calculate it. Now, like I said, this feels like overkill, but I just don't know. I can't rationalize it in my head without actually calculating it. That's just how I'm feeling. So I have 67.38 degrees there for that red angle. It's just coming up there. So if that angle is 67.38, then I can figure out the blue angle there. If I just do 90 minus 67.38, then I'm going to get 22.62. Oh, that one is just not happening. There you go. Yeah? So now if I go up to my little triangle, right, and I put those in, so the red angle is 67.38 and the blue angle is 22.62. Yeah? But it's a rectangle. So this corner here has to be 90 degrees because it's a rectangle. So that means that in the little corner here, the blue angle there and the red angle there have to add up to 90. I know that the blue angle is 22.62, so 90 minus 22.62 is going to bring us back to 67.38. So that's 67.38, and then you do the same calculation again, and you get this is 22.62. So now you can clearly see, because I have numbers on it, that those two angles are the same because they're both 90. Angle AFE is the same as angle EAD. Now I've actually found the angles, they're both 67.38, we don't have to say that. And then angle EAF equals angle EDA. Now, like I said, I feel like, see where I put that star there? I feel like from that line there might have been a way to just leap and say the red angle equals the red angle, the blue angle equals the blue angle, because they both add to make 90. I just can't find the rationale for it. You know, you're supposed to justify these things because they're isosceles, because they're alternate, you know, because they're, I don't know, whatever, corresponding angles. But I can't find that in the picture. Like, we do have parallel lines. Are they really? But they're not helping up there. Yeah, I can't see it. So that's why I went and calculated it, so I could actually wrap my head around it and prove to myself that they were the same. But they are. So all three angles are the same, which means it's similar.